we'll note that it is in fact assigned, just as we saw in the threat case, and just as we saw when we inspected the file on the local endpoint. So there's multiple ways of figuring out whether a particular binary has been signed, what it did, where it executed, where else it is on the network, and ultimately how it got there. So we've just taken a look at various methods of finding suspicious binaries or code running. That can be on your network by hash, as components of threat cases, or as nodes inside of threat cases of a particular technique that has been found, as well as various methods for detecting when new apps are installed or downloaded, whether they're signed or not, across your network. Another thing to investigate when you find these components is to basically request third-party intelligence from various sources, either VirusTotal or Sophos Labs or whoever else, just to get an idea of what a third party may think of a particular binary, either by detonating it in a sandbox or doing static inspection on it. And thirdly, if that binary has been executed, take a look at what it did. Take a look at its execution chain. Take a look at what it accessed, who it communicated with, what other processes it spawned, to get a better sense of whether or not this binary is something that you actually want on your network or even expect on your network. The actions to take while investigating is to isolate those systems from the network. That can obviously be done remotely. When you have decided to clean something up, mark it as block and clean, and the Sophos security solution will take care of it and remove it, as well as any other network destinations that it may have communicated with. If you find that they're malicious or unexpected, you can also obviously add those network destinations to a block list on a firewall or another network device. Now let's move on to scripting engines. Rather than compiled code, the instructions for scripting engines are usually delivered as plain text or sometimes encoded text. And scripting engines can vary from platform to platform. Some of the more common ones on Windows, obviously, is PowerShell and WScript. But this isn't limited to Windows platforms, obviously. Mac and Linux platforms have their own scripting engines and interpreters that can be fed instructions and code to do malicious and legitimate things. Usually instructions, legitimately anyway, come from a script file that's on disk, but that's not necessarily the case for maliciously given instructions. Those can be streamed or downloaded from, or scripts that are downloaded from the network and never actually hit the disk drive of the system being attacked. In a lot of cases, these scripting instructions are heavily encoded and obfuscated, and so that's usually done to prevent some sort of a streaming solution to take a look at plain text scripting instructions and basically be able to match a signature on it before it gets delivered to the target, as well as to sort of hinder somebody that might be looking at it later on. A lot of these scripting engines have a lot of built-in capabilities, the ability to retrieve and run pre-compiled code remotely, execute commands remotely, and essentially look around for different assets on the network that an attacker might be able to take advantage of. This is usually covered in the discovery phase of when an attacker lands on the network, looks around, see what access they can have, and figures out what the shortest path is to getting network admin on that particular network and expanding their attack. And usually these are done by using built-in commands in the scripting engines as well, or commandlets in the case of PowerShell. Some of the pros for the attacker and by using scripting engines is obviously they're available and allowed on most systems that an attacker might be able to breach. PowerShell has been around for years and years and years now. The instructions that are sent are text. They're not compiled instructions, and so they actually get less scrutiny in some security products for the delivery phase. Usually the web proxies and file scanners that exist on the network don't take a look at plain text scripting instructions in the same way that they look at delivered binary code. And they can also be made to be heavily obfuscated, although we'll sort of show how that's actually easily defeatable. Again, a lot of these cases, they use highly trusted, legitimate system tools, and not just scripting engine. And frankly, they have limitless uses in terms of from an attacker's perspective. Some of the cons, and again, pros for a defender's perspective, is a lot of the scripting engines that actually exist on Windows, at least modern Windows platforms, all support AMSI. which is a built-in mechanism to basically pass a lot of script blocks to a registered AMSI provider like a AV engine or some other security solution that's on the endpoint. And then so all scripting instructions and blocks actually get passed to the security solution to be inspected before they're able to be run. So that's a big plus. The other thing is that a lot of scripting engines have now implemented heavy logging by default. Not all of them, but anything that does end up getting run, usually there's a log of it for some sort of defender coming along later on and looking for indicators of compromise. Earlier, we noticed in our threat case that we had some suspicious PowerShell executions. So let's take a look at those with a little bit more detail. We've got PowerShell execution with a command line parameter that seems pretty obfuscated, calling another PowerShell instance with a pretty obfuscated command line parameter, and a third one, which is ultimately where a stager has been delivered. PowerShell instance, in each case, with a pretty obfuscated command line parameter, or a combination of which has been used to ultimately where a stager has been delivered. PowerShell instance, in each case, with a pretty obfuscated command line parameter, or a combination of which has been used to ultimately where a stager has been delivered. PowerShell instance, in each case, with a pretty obfuscated command line parameter, or processes remotely. So the way we can do that is using live discover and live response. We're going to give us a reason to start this console, and live response essentially enables an administrator to have remote console access to a system, even whether it's been isolated from the network. So in this case, we just have a command prompt, and we can run task list, type it to more, take a look at whether or not any sort of PowerShell executions are currently running. And there are, and we can kill those remotely by running task kill. Great. Now let's take a look at some more suspicious PowerShell executions, and we can easily do that using live discover and using a generic journal search query. So we'll select that query, and this query has been custom written and is available in our EDR query forum, but it essentially allows you to arbitrarily look for interesting executions with interesting parameters. In this case, we'll just give it -EC in PowerShell, let it run, and this will return all PowerShell executions with EC and -EC in the command line. We see we have 4 results, which are quite interesting. One of these has a parent process of WMI PRV SE, which signifies a remote execution. So let's go ahead and take a look at this command line parameter and try to de-obfuscate it. One tool that I use for this quite a lot is CyberChef. It's available on GitHub. And the thing with PowerShell encoded commands is that they're always encoded in the same exact way. They are always base 64'd, so you can drag over from base 64 and get a better approximation of what it did. And you can also decode text and change it to be UTF-16LE to get us the exact string that was passed to PowerShell. In this case, this is actually a couple layers deep. So in this case, we see plain text of the script, but it's being passed another block of obfuscated text. So let's do that again. Copy that in here, paste that in here, get rid of the decoding, and we get our next layer deep. We've got a little bit more plain text and some variable names that are coming out. But again, as is the layers of the onions, we have to unpeel. We've got another encoded string, so we do the same thing here. Get a little bit deeper, and ultimately the variable names tell us exactly what this is doing, as well as the script content. It seems to be writing an archive file with a ICAR file with a random number to the temp directory. And if we decode this final variable, we do in fact get the ICAR test string. So that's one way. There are many to decode and deobfuscate commands that have been passed to PowerShell or other scripting engines if they're base 64 encoded and if they're using standard methods of encoding or decoding. As we just saw, this may have skipped on the screen fairly quickly, but we started off with a fairly large bit of encoded command, a giant block of seemingly random text. We decoded it, base 64, got a little bit of plain text out of it, but then the second layer was also base 64 encoded, the third layer was also base 64 encoded, and then finally the encoded variable encoded icar was again base 64 encoded. So in this case, we actually had 4 layers of decoding that we had to go through by hand before getting an idea of what exactly that scripting instruction did. Now, in the case of any AMC provider, usually these script blocks are provided for them. So any registered AMC provider would actually have more, in this case, 4 opportunities to hit a detection on what that script was actually doing at each stage of the execution and deobfuscation, which is nice. Now, searching around for encoded commands, as we showed, is not that hard. One thing to investigate is essentially PowerShell commands with command line parameters that signify that the next block is actually encoded. Now, there's various ways and methods of telling PowerShell that this is done, either -e or -ec or -en, or the fully written out -encoded command. You can also look for invoking execution by looking for IEX. And then we can use those command blocks or encoded commands and put them into CyberChef to get an idea of what actually was happening in that execution chain. Also take a look at how that command was initially launched, what its parent process was, which user it was launched as, and ultimately what it did if it launched other processes later on. Keep in mind that a lot of legitimate programs also encode their commands. MS Identity Health and Insight Services use the fully written out encoded command parameter. So just because something is encoded doesn't necessarily mean it's malicious. In terms of actions that we can take, it's similar as before. We can isolate the machine, and in the case of running processes that are still live, we can use the live response console to list out the tasks with task list and kill the ones that we don't want running with task kill, and have those processes go away. Next, we'll look at various ways of running commands remotely. This can vary from classic methods such as using psexec to using scripting engines. psexec has been around for a while. It's part of the MS Sysinternals toolset, and generally speaking, it should be limited to as much as possible to who can run it on the network. Other ways of running commands remotely can use scripting engines such as PowerShell or the Windows Management Instrumentation framework. PowerShell actually ends up spawning wsmprov-host.exe on remote systems when remote PowerShell commands are run, and WMI can actually spawn WMI-PRVSC on a remote host. That would indicate that, that commands have been spawned remotely from another system. Included are some of the command parameters that are used and can be looked for in this case, but we're actually going to focus on WMI the most. So using WMI for the attacker is actually quite powerful. It's been available and trusted on Windows systems since Windows 2000 in various methods. It has limited default logging compared to some of the other scripting engines like PowerShell. And good news for the attacker is that a lot of the process parameters that are run remotely are obfuscated by default. In a lot of cases, you'll simply see WMI-PRVSC with -secured and -embedding command line parameters and not much else. It has a lot of powerful uses both from the discovery phase as well as the lateral movement phase, which is obviously its job. It is designed to be a management framework for Windows, but it can also be used for malicious purposes by an attacker if they gain access to systems. Some of the cons from an attacker's perspective is that WMI, since about 2 years ago, also now supports AMC, which is great because a lot of its instructions are now also passed to the registered AMC providers. And although logging is limited by default, extensive logging can be turned on for WMI, and the logs end up in event tracing for Windows in the event viewer. Previously, we ran a generic journal search query with PowerShell and -EC as encoded commands, and we noticed that the parent process of the process we were investigating was WMI PRV SE. So now let's take a look at the process tree that spawned from and try to figure out how that actually came to be. So we look for our tree search and pivot with the Sophos PID as the input parameter to try to figure out how this PowerShell instance was executed. And we see that it's been executed by WMI PRV SE, which was executed by service host and then services. So the chain sort of, or the trail sort of runs cold on this machine because we know from previous experience that WMI PRV SE is the way that WMI remotely executes commands on remote systems. So we know that at some point somebody on a system on the network ran WMIC and passed it the node and create parameters to get this to run on this system. So let's go ahead and do a search for that. We'll do a generic search again, take out the parameter, and look for WMIC.exe. And we see here we got fairly clear text running and command line of WMIC. We have the password that's actually passed in plain text, the node that it was attempted to be run on, the user, as well as the actual call create PowerShell and its encoded command. So we can trace this back from one machine to another if you have an EDR agent on both. It's also important to note legitimate activity. If we just do a generic search across all systems for WMI PRV SE.exe, we select all endpoints, we will note that there is quite a bit of activity from generic Windows administration and service administration that happens. Some of these may result in encoded commands being passed down the line. Some of these may result in scripting engines being called. But it's important to know what is normal behavior on a particular network or in a particular endpoint. This behavior, for example, would be completely benign. One thing to note is who the username was that ran either the remote command or the remote scripting engine that was called by it. And that's something to take a look at as well. So some of the things to remember while investigating remotely run commands is that you can easily search across the environment for executions of WMIC and WMI PRVSE commands, particularly focusing on WMI PRVSE as a parent process to a scripting engine. And that can be PowerShell, CScript, WScript, and pay particular attention to the user account that is actually used to execute those scripting engines. Rather than system or network accounts, as if it is a user account that's done and the command is malicious, or the execution chain is deemed to be malicious, it may signify that the user account that is being used has actually been compromised, and an attacker has access to those credentials to be able to move around the network. With WMIC specifically, look for the create or /node parameters being called on the command prompt, as those usually signify the process creation of a new process or a remote process. Ideally, those commands should actually be visible and so are easily searchable with the available tool sets. Also, it's important to determine the scope of the execution chain. Again, as before, what did it access, what it communicated with, what processes it spawned, and ultimately what files that it wrote or payloads that it may have dropped on systems. In a lot of ransomware scenarios, WMI is used to deliver and remotely execute ransomware payloads. It's also important to learn what is actually legitimate and normal behavior for your particular environment. It will be different for different environments. WMI PRV does launch VBS scripts and CScript engines from all sorts of directories. SCCM is a great example of how this actually ends up being used and implemented in the real world. And it's important to essentially know what the noise to signal logs look like in your particular environment, whether it's launching DISM host or MSI exec or PowerShell scripts that are based in the CCM directory. All those things could be legitimate, and you want to focus on the ones that are the most odd or weird in your environment and focus the investigations there. So some of the actions to take, again, while looking at a system, make sure it's isolated to limit the scope that the attacker has, as well as terminating new processes if they're still running using the live response console. And if you do find that accounts are compromised because they're being used to launch suspicious or malicious commands across the environment, definitely disable those compromised accounts or at least change their passwords. So to recap, remember to follow up thoroughly and investigate all the items inside threat cases, particularly threat cases that result from runtime detections. Look around for common system tool abuse. This can be PowerShell, WMIC, those sorts of things, and take a look at what those commands actually did in your environment and whether they're expected. Remember to learn what is normal baseline behavior for your environment to sort of help you separate the wheat from the chaff. And look around on the internet for more great tools and queries that you can use. Some of the queries that we use today, the generic journal search query, for example, is not available in the product, but it is easily importable and has first been posted in our Sophos EDR query forum. The link is below. So again, happy hunting, and thank you for your time.
Bien, súper interesante esta charla por parte de Ashek. Recuerden, tenemos ahí más informaciones sobre los recursos, sobre esta academia. Aquí está el link, se los ponemos aquí en pantalla para que puedan ustedes consultar más recursos, más informaciones. Como podemos ver, esta charla durante Ashek que presenta que todas estas herramientas que tenemos como parte de los mismos sistemas operativos para la gestión, pues también pueden ser utilizados para la ejecución de códigos remotos en caso de un ataque o un equipo comprometido, ¿no? Entonces, lejos de estas mismas herramientas pueden ser ese punto de apoyo, ese punto de partida para arrancar una amenaza y pues también ver las diversas herramientas, no solamente la parte de lo que es la solución per se de Sophos EDR, sino el poder complementarlas con otro tipo de herramientas, poder hacer las traducciones con esa parte de MasterChef para algún script de base 64 hexadecimal, poder tener todas estas herramientas. Y esto es parte del objetivo que queríamos mostrar y que Ashik nos dio una revisión, sí, de alguna manera bastante rápida, bastante fluida, pero que son precisamente la intención de mostrar todos los recursos que podemos tener para hacerle frente a un ataque. Dani, ¿algún comentario por ahí? ¿Qué te pareció la sesión?
La verdad es que sí, está buenísima y algo que me gusta mucho, ¿no? Que incluso al final Ashek lo comentaba, es tratemos de analizar detalladamente realmente cuál es un comportamiento normal dentro de la empresa y por más mínima que llegue a ser una alerta, es importante hacer esta investigación porque muchas veces somos víctimas de un ataque y cuando hacemos ese análisis en retrospectiva, nos damos cuenta que sí, a lo mejor un usuario recibió un correo malicioso hacía un par de días, pero ahí lo dejamos, ¿no? En cambio, si hubiéramos hecho esa investigación detallada, vimos, ¿no? Con estos queries que nos mostró Ashek, la capacidad que se tiene de analizar cuáles son procesos, servicios, ¿no? Procesos padre, procesos hijos, para realmente entender qué es bueno, qué es malo dentro de la empresa y empezar a tomar las acciones pertinentes, ¿no? Para neutralizar a un atacante en caso de que esté presente y simplemente recordarles, ¿no? Como vimos, herramientas como las que mencionó ahorita Eric, CyberChef, toda la ejecución de código que se puede realizar, análisis a través de los queries personalizados, es realmente importante, ¿no? Que ustedes, aprovechando todas estas funcionalidades de EDR, las estén ejecutando, ¿no? Y en caso de que no tengan un equipo que esté analizando esto o que no tenga este expertise, pues bueno, para eso también Sophos cuenta con el servicio de MTR, que es todo un grupo de expertos, de threat hunters, que realmente van a estar analizando, ¿no? Todo el comportamiento dentro de su empresa, el comportamiento normal de los usuarios, cuentas creadas, URLs, o bueno, hacia dónde se navegan, realmente todo ese análisis lo van a estar haciendo estos expertos 24/7. Entonces, en caso de que ustedes no tengan hoy en día un equipo de seguridad dedicado para esto, pues Sophos puede hacerlo por ustedes.
Exacto, eso es súper interesante y ese ya es el objetivo de toda esta serie de sesiones que vamos a tener en los próximos días. Como continuando con las preguntas, no sé si por ahí tenemos, preguntaban mucho sobre el tema de MTR, precisamente cómo EDR puede complementar, hacer todo, pues la herramienta per se tiene muchas soluciones, esta parte del root cause analysis, que es nuestro punto de partida para un caso de amenaza, y de ahí poderlo escalar de una manera guiada, intuitiva por la propia herramienta, obviamente haciendo uso también de algunas herramientas complementarias como MasterChef que vimos aquí para que nos ayude a hacer ese análisis. Perdón, MasterChef, me equivoqué, me quedé con el programa, perdón, el CyberChef para hacer todo ese análisis completo, ¿no? de las amenazas. Entonces, sí, realmente pues hay muchas opciones. El objetivo es continuar con estos capítulos y al final de las sesiones, la última sesión, pues va a ser un compendio de todos estos herramientas, todos estos conceptos revisados para que ustedes lo vean en vivo completamente. Mariana, ¿por ahí algún comentario respecto a los registros, la parte de preguntas respecto a la parte de participaciones y todo este tipo de cosas?
Sí, correcto. Bueno, nada más recordarles que vamos a tener disponibles pronto las grabaciones de estas sesiones. Hoy es la segunda sesión, así que pronto las vamos a tener disponibles. Y bueno, no sé si ustedes tienen algún otro comentario.
No, creo que vamos a lanzar ahí
Perdón, Eric,
Adelante,
solo complementar, porque acá estoy viendo que nos lanzaron una pregunta que nos dice, ¿no? Si ya utilizo hoy en día el antivirus de Sophos, ¿cómo puedo hacer uso de estas funcionalidades? Recuerden que para todo este tema que nos mostró Ashek, ¿no? De los queries que vienen ya predefinidos o los que ustedes pueden personalizar, la licencia mínima requerida es la de EDR, que bueno, también como vemos, ¿no? Con el panorama actual de amenazas, ese sería el mínimo indispensable que todos deberíamos tener.
Perfecto, entonces estamos lanzando una última pregunta. Recuerden, aquí está el recurso con la información de lo que es el programa de la academia. Vamos a continuar con nuestra agenda para el día de mañana. Vamos a estar con Chris, que nos va a estar hablando sobre, a partir de un punto de apoyo dentro de nuestra red, cuando se tiene este acceso, cuando se gana este acceso, ¿qué se puede hacer ahí a nivel de un ataque a partir de que yo ya tengo una infiltración o que ya tengo un punto de partida dentro de una red remota? Ya vimos anteriormente ahorita con Ashek toda la parte de ejecución de código. ¿Qué pasa ahora cuando ya hay un ataque, cuando ya está perpetrado el sistema y ya tenemos allí pues un código, un puerto abierto, una brecha abierta de seguridad? ¿Qué es lo que puede hacer el atacante? Y obviamente, ¿qué es lo que puede hacer precisamente nuestra herramienta? Y Chris precisamente nos va a estar mostrando estos detalles de cómo estar visualizando, cómo poder aprovechar toda la visibilidad que nos da la herramienta para poder ayudarnos a hacer la detección y obviamente los mecanismos de respuesta sobre este tema. Perfecto, entonces por ahí creo que se lanzó la encuesta. No sé si tenemos ahí un tiempo determinado.